folks, the next few weeks of class are going to be studying trigonometric functions. So chapter 4 and 5, as you can see from the updated schedule, it's going to be taking up most of the rest of our semester. It's a very important branch of math that a lot of people don't have a very great or very deep understanding of. And coming out of high school, going into college, I definitely thought I knew what they were, but I didn't really have a good understanding of what trigonometry was, the history, and uh, that's kind of my goal for the next develop that from the very basics. So we're going to start with just a little bit of an introduction. Uh, then we're going to talk about what is the mathematical definition of what a trigonometric function, and then we're going to discuss applications to so many. We're going to focus on triangles, um, a lot of stuff in physics as well, but they're very important in the field of math, physics, natural sciences, and you'll be able that should become apparent as we start studying properties of them. Um, Anyways, we're going to be starting with the beginning of chapter 4. After we get through some of the basics, we're going to skip ahead to chapter 5 and then go back to the end of chapter 4, because chapter 4 is on some more what we call analytic trig. I usually like to do that after the applications, chapter 5 in triangles. So anyways, we're going to skip around in the book a little bit. Hopefully it doesn't get uh, confusing. It shouldn't. It should be still be. You should be able to follow through with your read problem. Anyways, let's get right into it. So if you search up what is trigonometry in Wikipedia, you'll come up with this article or this page exactly. This, but what it says is the study of angles, triangles, um, and what I wanted to discuss a little bit about the history of trigonometry. There's actually been a more recent discovery in the last few years about ancient trigonometry. If you're reading the slides here, uh, what it says is the Greeks focused on the calculation of chords, while mathematicians in India created the earliest known tables of values of trigonometric ratios. So uh, we think that Indians were the first to trigonometry. Now, ancient trigonometry was very different than modern trigonometry. Modern trigonometry mostly we work with mathematical functions called sine and cosine, and deal with wave functions. And it like if you ask the average person what is trig, they'll often think about or they'll say something along the lines of sine, cosine. They might say the unit circle. They might say triangles, SOHCAHTOA. All of those are important aspects of trig, um, and we're going to get to all of that. But trigonometric ratios, it kind of gives us the basic sense of why ancient man cared about trigonometry in the first place. So let me end the slideshow here for a second, so I can sketch on my try to explain what like a trigonometric ratio is. So let's say we're trying to construct a building or trying to study the angles or whatever in the purposes of building. Like say we wanted to build um, like a structure that was, I don't know, 100 feet tall, or wanted the base to be, say it was like 200 feet along the base. And we wanted to study, say we had the question, what should this angle be if we were trying to build a support beam or something in the context of construction. um, the question would be, well, how long would this beam be? As you probably remember, we could use the Pythagorean theorem to do that. But other questions such as angles of construction um, are often quite important, especially when considering force. But so what I'm trying to explain here is how did ancient man, why would they have used trigonometry? But one thing like a trigonometric ratio, this demonstrated by what I'm trying to say. But let's say we're taking the ratio of the opposite side to the angle, and the adjacent side is how we often refer to these sides with respect to the angle theta itself. But that ratio in this case would be 100 to 200, or simplify to 1 to 2, or 1/2 ratio, or 2 to 1 if you were to reverse the ratio. But that's an example of what we call a trigonometric ratio. You can take a ratio between any of the sides of the triangle, but what early men often had in their tables was with respective angles and pairs of these trigonometric Like for example, say we had a different ratio like 7 to 11 instead. That would have its own properties, and their tables uh, were kind of solutions to various different ratios, so that if they were to use construct something, they could kind of degrade those numbers down to a simple ratio, and they would understand, okay, what are the angles of this triangle? What are all the properties of it? And I'm not an expert, but that's kind of my interpretation of what that means. Anyways, let's get back to the slides. And so, anyways, but my going back to the history thing that I was talking about, it's actually been recently discovered that the Babylonians, much longer ago, around 3700 AD, actually used trigonometric ratios as well, which was not known until these tablets were found. So we found these tablets, and it kind of changed our understanding of how long have people known or been using trigonometry in some form. So summary, it's been around for a long time, and it's very important in general construction for various reasons, which we're going to come back to. But anyways, this was the tablet that was found, and we're not going to get into Babylonian number systems, but I thought that was kind of interesting. And we don't necessarily know everything about the history of math, because sometimes we're still uncovering um, ways that early man. Now, modern trigonometry is quite a bit different than historic trigonometry, so we're going to transition to focusing on how are the trigonometric functions defined in a modern sense, and then we're going to work our way back to how we use it to, say, solve the same problems that ancient man tried to solve, aka how do I solve triangles. We're going to really get into how do we solve any triangle as our final goal, well, in chapter 5 at least. But there are a lot of different ways that people define trigonometric functions. We're going to start with the most mathematical, my preferred mathematical definition. SOHCAHTOA is a different type of a definition of trigonometric functions, which is very good. And if you remember the idea of SOHCAHTOA from high school or whenever, that's good. We're gonna come back to that, because one of my issues with SOHCAHTOA is a lot of people memorize SOHCAHTOA, but they don't really kind of understand why does this make sense? What is the theoretical origin of this? So we're going to table that definition and start with a more mathematical definition of how the trigonometric functions are based on the unit circle. So the unit circle is a very fundamental concept in trigonometry, and that's where we're going to start. But before we get into all the technical details, there are six trigonometric functions, as you can see from the slides. But really, there's three unique names: sine, and its cofunctions cosine. Those are kind of the two major, uh, most commonly used trigonometric functions of the bunch. The third one is kind of like the third wheel of the whole gang, is the tangent function, also very important, you know. And anyways, the other three, secant, cosecant, and cotangent, all of them are called trigonometric functions. The last three that I just mentioned are less so important, and less commonly seen, but they're all very similar at the end of the day, and they're all within the same category because they all behave almost not exactly the same, but they're all based on the same definition on the unit circle. But what I wanted to mention is there trigonometric functions have their cofunctions, like sine is cofunction to cosine, secant is cofunction to cosecant, tangent is cofunction cotangent, tangent. That I don't know if I said that right. Whatever. But that has a specific meaning, which has to do with complementary angles within a triangle. So in a triangle, especially if the triangle is right, which all of this only applies to right triangles, is another thing that you're going to hear me say way too much in these videos. But anyways, complementary angles, we'll circle back to that later as well. But there are reasons to their names, and I'll put a link to the history of the origin of what is sine, what does tangent, what does secant mean? But tangent means to touch, roughly, in Latin. Sine means to curve, I believe, and then secant is cut, if I recall correctly. But it's from Latin, and the names that's kind of the origin of where these names came from. Now, the last thing I wanted to mention before we get into all the definitions and all the math is why are these so important, and how are they relevant in modern fields in math and science, and all that stuff. So let me move that. Um, so in math, their trigonometric functions are a baseline skill which is needed for pretty much every subject. So any math class you're going to take that's starting with calculus and moving on, it's like something that is just assumed that we know about. Now, most people will not necessarily assume you have a super deep knowledge, but the basics are critical across the board. So in geometry, it's very important when we're dealing with any object involving circles or triangles. So we're gonna that's going to be one of our primary focuses is on geometry. But also additionally in subjects such as physics, the study of periodic phenomena. So anything periodic phenomena is to describe what that means is something that uh, goes around and comes back, or bounces up and down, or circles, has a rotational movement, anything that it kind of goes through the same motion over and over and over again. We often refer to that as periodic phenomena. And the sine and cosine, those mathematic functions, are turns out are model exactly that phenomena perfectly. Now, there's other types of periodic functions besides just sine and cosine, which we're not going to really get into that too much in this class, but uh, sine and cosine are the most foundational periodic functions. In the study of complex numbers, trigonometry is also very important. And just to sort of review back to when we talked about numbers such as 2 plus 3i, or when we in algebra when we were talking about the imaginary unit I, which is square root of minus 1, we described, we discussed how in the real number system, no number has a square root which is negative, and I, that fundamental number, was our algebraic solution. It's kind of a weird number because it's hard to understand because it's just different, but its importance to algebra, I think we already got to that. But in understanding how these numbers work, trigonometry is actually very relevant, which is something we're also probably not really going to get into in this class much at all. But it's weird how circles and triangles pertain back to one of the reasons I love math so much is there's so many odd relationships between all of these things we study. We study all these seemingly random concepts, but they all link together in this very fascinating way, and have very interesting relationships. So if you ever take a course called complex analysis in math, if you're an engineer or physicist, or but most of you guys probably would not have to take that course, you'll start to see the connections between imaginary numbers or complex numbers such as this and how it relates back to trigonometry.